So our topic of discussion today is going to be section 9.5, which is what we're going to be doing is solving quadratic equations by graphing. So our objective today is basically just solve equations by graphing. The first thing that we need to understand is, again, what is truly, or what makes a quadratic equation. And that's anything that can be written in the form ax squared plus bx plus c that equals 0. So the difference from what we were talking about to what this is that now we have this equaling to something. And so this is equal to 0. Now there's a couple things that we need to remember is that a cannot be 0 and b and c can be any number. So it doesn't matter what b and c are as long as a does not equal 0. And so basically what we're going to look at is we're going to look at how we can make this true. So how can we make this equation ax squared plus bx plus c equals 0? How can we make that true? And the way that we do that is that we solve this. So what we're looking for is we're looking for a solution. And that solution is find where there's some x value when it's substituted makes the equation true. So we're looking for some x value that we can put into ax squared plus bx plus c equaling 0. Now remember, when y equals 0, remember what these are is where really we're just going to find the zeros of the function. So remember I told you that finding the zeros is actually something that we want to look for and that can tell us a lot about the function. And then so what we can do is if we can find these zeros, what's going to end up happening is we're going to get our solution. So when we find the zeros of this function, we can find the solution. And remember, what we want to look at is we can remember that there can be 1, 2, or no zeros to a function. So that there's 3 possibilities. We can either have 1 0, we can have 2 zeros, or we can have no zeros. And so basically there's 3 different types of solutions that we can get. And we're going to do this by graphing these functions. And in order to solve these by graphing, first of all, we need to do 3 things first. And so the first thing is we need to write our equation equal to 0 in standard form. So basically the only thing that we're going to write is we're going to make sure that in number 1 we have ax squared plus bx plus c equaling 0. So that's the way that we want to write this. So we get the standard form all on one side of the equation, then we set it equal to 0. The next thing that we're going to do is we're going to graph the function. So we're going to graph the function like we know how. And then we're going to find the zeros. So in order to do this, in order to solve this quadratic equation, we need to write the equation equal to 0, make sure that it's in standard form, which is in the form ax squared plus bx plus c, which is shown at the bottom here. Then we're going to graph it. So we're going to graph the function on a coordinate plane, and then we're going to find the zeros. So if we look back just for a second, remember how we graph these quadratic functions is we need to find the axis of symmetry, so we find the axis of symmetry, and remember we do that with the equation x is equal to negative b over 2a. Second thing is we need to find the vertex. The third thing that we're going to do is we're going to find a couple points. So find 1 to 2 points. And then the last thing is we reflect every point that we put on our graph over our line of symmetry. So we're just making sure that we get a couple points that we can reflect it so that we have a good indication of where the graph is headed so that we can estimate our 0 points. So we just want to make sure that we get enough points so that it will go through our x-axis so that we can find our zeros. Because remember, to find the zeros is where it crosses x-axis. And so that's when y is equal to 0. And so what we're going to do is we're going to work a couple examples to show you how this works. So the first thing that we need is we need to get this in the standard equation form, so the standard form of this quadratic equation, which it is, and then we have it equal to 0. So the first thing is we need to do is we need to find our line of symmetry. So our line of symmetry. And we find that with x equals negative b over 2a. And what happens here is our b, since we don't have a b here, because remember this is bx, we don't have a bx, so our b is equal to 0, and our a is equal to negative 1. And so we get x is equal to negative 0 over 2 times negative 1. Well, that's all just going to equal 0. So our line of symmetry is just simply right down the middle. And then I've conveniently placed that in red. So this is where x is equal to 0. The next thing that we need to find is we need to find our vertex. So we plug in x into this situation here. So we say negative 0 squared plus 4 equals y. Because remember, we're looking at it from a y standpoint. And so when x is 0, y is equal to 4 because this goes away. And so our ordered pair for our vertex is just 0, 4. So let's put that on there. So 0, 4, which is right here. So this is our vertex. And we know that this is facing downward because our A is negative. And so now we need to find a couple points first. So 2 points. And the reason I choose 2 points is because this vertex is the same thing as our y-intercept. And so that won't really help us with a point to reflect. So I'm going to choose the 2 points, negative 2 and negative 1, to plug in. So if I plug these into my equation, I get negative 2 squared plus 4 equals y. And then over here I get negative 1 squared plus 4 equaling y. And so what I end up getting is I get negative 4 plus 4 equals y, which is y equals 0. So my ordered pair for this one is 0, or not 0, but opposite way. We get negative 2, 0. And then over here we get negative 1 plus 4 equals y. So y equals 3. So my ordered pair for this one is negative 1, 3. So I can go ahead and plot those. So negative 1, positive 3 is right here. This is 1 unit away from our line of symmetry, so I can also put a point over here. And then I go to negative 2, 0, which is right here. That's 2 spaces away from our symmetry line. So I'm going to reflect a point over here. And then what I'm going to do is I'm just going to go ahead and make a curve that fits all those points. And we can see we're looking for the zeros here, and our zeros were conveniently found actually when we were doing our computations. And so here is a 0 here, and here is a 0 here. So we're looking at these two, and these two are our zeros. And so our solution here, so our solution to our original equation is we have 2 zeros, and so our solution is x equals negative 2, positive 2, because that is where the values that we plug into our equation that make it 0. So that's our solution. So that's what we're looking for. The zeros the zeros that we find end up being our solution. And so if we look at this last example, the first thing that we notice about this is not in standard form, or this is not in an equation form. So I have to make it that way. And so the simple thing that I would have to do here is just simply subtract 2x squared from this side, subtract 2x squared from this side, and so what I end up with now is I end up with negative x squared minus 8x minus 16 equaling 0. And so now that's in the form that I want. So I need to find my line of symmetry, so I use x equals negative b over 2a, which just happens to be negative 8 over 2 times negative 1, which is 8 over negative 2, which gives me negative 4. So I go to negative 4 and I put my line of symmetry, so 1, 2, 3, 4. So this is a rough sketch of what my line of symmetry is going to look like here. This is x equals negative 4. Next thing I do is I need to find my vertex. So I know my x, which is negative 4. So I go back to my original equation and say y equals negative 4 squared minus 8 times negative 4 minus 16. So I get negative 16, because that negative 4 squared is positive 16, then we make it negative, plus 32 minus 16. And so what happens here is we get y equals 0. So our vertex then is negative 4, 0. So we can go ahead and place our vertex on our graph. So negative 4, 0. So it happens to be here. Now the next thing that we are going to notice about this is that since our vertex is on our line of symmetry, and it's also on our axis, we know that vertexes are either minimums or maximums. So vertexes are either minimums or maximum. And by looking at this equation, this change equation that we have here, we know that our graph is actually going to end up pointing downward. Now we don't know what this is exactly going to look like, but we know that this is going to end up being some kind of maximum. So can we assume that this isn't going to cross this x-axis in any other place? Well, yes, because we know that no other point is going to touch this. So really what we have is the only 0 that we're going to get is the 0, negative 4, 0. And so our solution then, for our equation, the only value is when x is equal to negative 4. Because we can see when x is negative 4, that's the only place on this graph that it's going to touch the x-axis, and so it's our only 0. And so that is also our solution, because remember, zeros equal solutions. And that's it. So if you remember nothing else from this video, remember that zeros equal solutions. Zeros equal solutions. Zeros equal solutions. And so really, the last part that I told you is that we needed to graph a couple points. Well, we could graph a couple points to get an idea of what this graph looks like, but we don't necessarily need to, because we can see here that the rest of these points don't matter, because all we're looking for is zeros. And we know none of this part of this graph is going to be a 0, none of this graph is going to be a 0. This is the only place where that vertex is. That's the only place that we're ever going to have a 0 on this graph. And all that we need to know is that zeros equal solutions. Zeros equal solutions.